Diagram shows the graph of the probability density function f of a random variable x. Part A, we need to find the value of the constant k. The probability density function assumes positive value from 0 to k, and we know that the area under the graph, this part here, equals 1. So the area of the triangle is 1, which is the total probability. The area of a triangle is half times base. Base has a length of k, and height has a length of half of k. This must be 1. So 1/4 k squared is 1. Multiplying throughout by 4, k squared is 4. K is plus minus square root of 4, which is 2. But over here, k must be positive, so we have the value of k to be positive 2. Part B, using this value of k, find fx for x in between 0 and k inclusive, and find the expected value of x. So first, we must find fx first. This is a straight line with decreasing slope. So fx is in the form of mx plus c. Since k is 2, this is 2, and that is 1. We know that the y-intercept c is 1 here. So from here, fx is mx plus 1. We need to find the slope. The slope of this line, m here, is given by y2 minus y1 over x2 minus x1. There are 2 points here. The first point here has coordinates 2 and 0, and this point has coordinates 0 and 1. Then the slope of this straight line is 0 minus 1 over 2 minus 0, which is negative 1 over 2. Fx is therefore negative 1 over 2x plus 1 for x in between 0 and 2 inclusive. We need to find the expected value of x. The expected value of x is the definite integral of x, fx, from 0 to 2. So we are integrating x fx. Fx is negative 1/2 x plus 1. And we can write this as negative 1 over 2 x squared plus x that we are integrating. That will give us, well, when we integrate x squared, we have x cubed over 3, which is negative 1 over 6 x cubed plus 1 over 2 x squared from 0 to 2. Evaluating, we have negative 1 over 6, replace x with 2, that will give us an 8 plus 1 over 2, that is a 4. At 0, everything is just 0. So this will give us negative 4 over 3 plus 2, which is 2 over 3. The expected value of x is then 2 over 3. For part C, we need to find the value p such that the probability that x is in between p and 1 is 0.25. The probability that x is in between 0 and 1, that is the definite integral of fx from p to 1. That is 0.25, which is 1 over 4. Now we are integrating fx. fx is negative 1 over 2x plus 1. So we are integrating this with respect to x and setting that to 1 over 4. Upon integration, this is x squared over 2. We have negative 1 over 4 x squared plus x from p to 1. That is 1 over 4. Evaluating, we replace x with 1. That will give us negative 1 over 4 plus 1 minus, now we replace x with p. That is negative 1 over 4 p squared plus p equals 1 over 4. So negative 1 over 4 plus 1 over 4 p squared minus p equals 1 over 4. We can write this as 1 over 4 p squared minus p. Negative 1 over 4 plus 1, when we move that 1 over 4 over to the left, we have negative 1 over 4. So that will give us a positive 1/2. This equals 0. Now this quadratic is hard to look at. Multiply throughout by 4, so that p squared minus 4p plus 2 equals 0. We cannot factor this, so we can use the quadratic formula. In this case, a is 1, b is negative 4, and c is 2. Using the quadratic formula, p is equals to negative b. The negative of negative 4 is positive 4, plus minus square root of b squared. The square of negative 4 is 16 minus 4 times 2, 4ac. That will give us an 8, all over 2a. We have 4 plus minus square root of 8 over 2, but square root of 8 is 2 root 2 over 2. So we have 2 plus minus root 2. Now p here is either 2 plus root 2 or 2 minus root 2. Let's look at it. The probability that x is in between p and 1, this indicates that p must be less than 1. And the 2 plus root 2, this is not the solution. The value of p that we want is 2 minus root 2, since it must be less than 1.